Hey guys, Matt here from Henry Shine, just doing a quick video about the Asiga 3D printer. So obviously the main one that we sell is the Asiga Max UV. So by being UV, what they're meaning is the wavelength for the light is 385, whereas a lot of other printers are 405. So the 385 tends to print better using clear resins. So you'll find a lot of the time with the 405 resins, they'll have to put a lot of pigments into the clear resin to allow it to actually cure. Obviously, that's the beauty of the 385 wavelength, is that it's going to cure the clear a little bit better rather than adding in a whole heap of different colors to allow for it to print well. So the Asiga is called a DLP printer. So essentially the three main types of printers that you'd see are going to be a DLP, which is a projection light, your SLA, which is like the Formlabs where it's a little laser that will paint each layer on. Or then you've got an FDM, which is the one that you see at Aldi, which is like a little nylon tube that gets fed out, heated, and then built on top of one another that way. So DLP out of FDM is not really used in dental, at least not by many places that I know of. The DLP and SLA are the two that are mainly used in dental. DLP is used more so because it's faster and the accuracy is very high. SLA tends to be a larger build platform because what happens is on a laser you can cover that big area and it doesn't go out of focus. However, it's slow to draw each layer. On the DLP, obviously it's one projection. So because it's relating to pixel size rather than a laser, it can't get too large because obviously the larger the image, the larger your pixels, meaning that the less accurate it can be. So essentially the Asiga, being a DLP, is fast and obviously it's one of the most, if not the most accurate printer on the market for that price range. So going in, Asiga's really good. So you can log into the Asiga website. So I'll just jump in here. So if you go on asiga.com, you can log in, you can use your account. Once you've created an account, you can log in, just register with a new account there. And then from here, you can see we can come down here and you can go material library. So these are the resins that Asiga have created INI files for. So this is what makes them such a good 3D printer. They're totally open. So therefore, if you decided you wanted to use Dentacar, Keystone, GC, Nextdent, Whipmix, any of those, you can just basically go in, pull the file off, and you can start printing with that particular resin. So now the thing that makes it able for the Asiga to be able to print any of those resins is, unlike the other machines out there, which are more closed systems, the Asiga has got 4 sensors down the bottom of the build platform, build tray. Let's call it build tray. So there's 4 sensors down the bottom of that build tray. And what they do is they sense when the resin has flown all back down and it's nice and even. So you imagine as a printer comes down, the resin gets squashed out, a bit of resin displacement, and then the printer will go back up and then the resin will flow back in. Once the resin's flowed back in, those 4 sensors are going to read that it's perfectly flat and then it's going to go again. So other printers, they don't have those. So they just worked on timing. And if your resin doesn't fall within their times, then that's just bad luck, which is why they've got their own resin sorted, like Nextdent. Let's say Nextdent have their own, call it 12 or 14 resins that they've got. So they've got all the settings in there for that. So why would you need any other resins? Because obviously they've got a resin for everything dental. So that's their philosophy. But obviously Asiga want you to have a truly open printer. So they've included those so that means that you can use any resin from any of those companies. So that's that. There's also within here, there's training videos. So within here, it will also show you, which obviously I download these onto your computer, how to clean optics, how to calibrate 0 position. So this is a max here, how to clean the build tray, zero position, and also a user guide. So these three things I download and put them on your computer on the install, as well as going through everything. So that's our website. So it's got everything you need to know on there. The program itself, you double click, you would install, or I'd install the Asiga Composer. Software is free. And then once it installs, it comes to this page. So to create a new file, we can go new. If your printer's, now I'm not connected onto a printer here, but if your printer's hooked up, then you just choose it up here. This is where we choose whatever resin that we wanted to print from. So let's just go down to model, and you can choose your slice thickness, any of these thicknesses through there. So in a perfect world, if you wanted to print it off a model really fast, you go to 150 micron, which is not the accuracy, but that's just a layer thickness, or usually about 100 is going to be a fine print. Depending obviously on what you're printing. A model, that would be fine. If you wanted to do a splint, I'd most probably go 50 micron. If you wanted to import in resins, this is where you'd import them in over here. And then these are the resins which I've imported here. You can see all the Nextent resins in there. So once you've chosen your material, your slice thickness, we can go next. And now this is essentially the build platform. So how this is going to print out is it's going to print out upside down. So whatever we print here, it's going to start at the top here and make its way down as it's printing. So once that's there, we can then start to choose our files that we want to print. So you can do it two different ways. You can come and import in, or you can also just drag something and bring it over. So let's say, do I have a model? Clear lower jaw scan. Let's bring this in. You can choose if you want to choose platform center and go OK. So this is a denture base, so never mind about the what we're printing at this point in time, but that's just something that we can print. So you can see how it's brought it into the middle of the platform. I'll try and actually, I'll just click it, delete. I'll see if I can find a model so that you can see how a model's going to get put on. So let's just go. Search model. No. Splint. Bugger it. We'll do a splint. So we'll drag the splint in. I'm just going to choose platform center. Okay. So you can see it's dragged it into the middle. So generally when you've got a model as well, it will drag it into the middle and it will set the flat surface on the platform. So from here, once we've got it on there, now let's say we didn't want to print on the fitting surface of the splint. So I'm going to left click, highlight it, zoom in. So to start to rotate this around, if we wanted to rotate it around, can you see how we've got green, blue and red lines? So they're symboling our X, Y, and Z axis. So depending on where you are, it's going to bring those axes into rotating it around. So if I click over here, you can see I hold down right click, the arrows turn blue. So we can spin this around and take it back to where it was. Almost. There we go. So that's on one axis. We come over here. We're going to rotate this around and we're going to go on a different axis. So you can see right now that's changed it around. So if you want to go directly to an axis, hold down X and grab this, and then we've got the X axis there flipped around. Let's say if I also grabbed here and go Y, can you see how it changes what axis we're on? So see how right now if I were to go Y, see how it puts a green line in the middle? If I hold it down, X, so it puts a red line through there. And what's the other one? Z. So each way it's going to put that line through the middle so you can see what way you're rotating it around and what way it's going to spin around. So from here, once it's moved into the middle, you can go to generate supports. I'd suggest always starting off, keeping it all how it is. Cool. And then once all the supports are on, then you can play around from here. Let's say close. You can add some more supports if you wanted to. Right now, that's going to be okay for me. I'm okay with that. And after you're happy with the supports, we can go into build time. You can test to see how long it's going to take to build. So this one's 33 minutes and base plate thickness. So you can adjust your base plate thickness here as well. So can you see, if you can see that little yellow and gray line? So that is our base plate thickness. So you can see as I brought that down, the time came down of how long it was going to take to print. So we can change those settings in another step as well. So if I go close, so let's say hypothetically we wanted to change our support structures. Let's say support angles. Once you get good at it, you might want to bring your support angles down to 25%. Support spacing. So these will all change. If you wanted to maybe reduce the amount of supports, this spacing figure is going to have to go up. And then we can just go apply. So now with these new settings, this should hypothetically give us less supports. But obviously with the less supports, there's a higher chance of it failing. So you just want to make sure that, you know, what you are printing at initially, you just use your factory settings, which I think this is most probably more on like 4.5 down here. And then obviously your overshoot is the amount of distance that this is going to go through the splint into the printed surface, so that you're making sure that obviously you're not going to have any supports fall short. So let's just go apply now. This will put on extra supports again. All right, cool, done, close. And now from here, we can go into building. So in this build section, so this is all set up. Next, so base plate. So once again, I know it's a bit hard to see here, but can you see that yellow line that goes through there? So that is this base plate thickness. So if you choose full, that means that essentially this whole build plate will get printed on. If you choose shadow, it's only going to be the area around whatever you're printing. Intersecting, sorry, phone's ringing. You've got intersecting or underneath. So if I tick underneath, so can you see that the model lifted up over the top of that base plate? Or if I go intersecting, it's going to start to print with the supports into it, intersecting obviously the base plate. We can go next. There's also a fast print mode. So you can, if you wanted to, print it off fast print, or you can do it on fast print. So this also in here is all the settings that you can play with once you get really good at using the printer. So you can see we got burn-in range. So the burn-in range is literally the first layer, or this section in here, base plate. So this is our base plate in the yellow part, and then the rest is normal print time. So once again, you can change burn and wait time after exposure. You can separation detect window. So you can put a whole heap of different settings in here once you get good and up and running. And then you go next. Then you can see how it's going to be printing out, and you can call it build name, whatever you wanted to test, and you can send that build. So it gets sent to the printer. From there, you can use, once your printer is connected, you can hook up to your printer by using that printer web interface just up there. And you can do quick views by clicking on these items. You can zoom in or out that way, upside down. So there's all that. And then obviously other ways that you can rotate it around as well. So let's say if I were to remove support file. So you can also use these settings here where you can rotate it around depending on whatever angle you wanted to rotate it around on. So there's all these settings. So if I were on X, I can rotate it that way, Y, I can rotate it that way, and Z. So yeah, they're all your settings. I wouldn't suggest doing any sort of scaling because obviously you don't want to change the size of your object in the printer. And that's it. That's pretty much how it all works. It's pretty straightforward. And then, yeah, hopefully you guys get a little something out of that and enjoy.